Hey friends, here we are working on chapter 10, lesson 4, compare populations. Okay, this is going to be some good stuff, some possibly heavy stuff. So let's just jump right in. We've got two different ways to describe data. Okay, we can describe the center of the data. That's our measures of central tendency. We can also describe the variation or how spread out. Variation could be known as the spread, how consistent, how close are the numbers together, okay? And then measures of the center is trying to figure out where is the middle of your data. Measure of the center, we've already talked about several times. That's our mean, median, and mode. Okay, so mean, remember, you add, that's what most people mean when they mean the average. And that's you add all the numbers, and you divide by the number of numbers. Okay, the median is the middle number after you put them in order. And the mode is the most frequently occurring. Most frequent number, okay? So mean, median, and a mode. Now each one of those kind of has, well, the mode, not really, mode and range, but the mean and the median have kind of a matching way to measure the variation. Okay, so measures of variation, if we're going to use the mean for variation, we're going to want to use the MAD, or the mean absolute deviation, okay? And we'll talk about how to calculate that in a minute, but we can write it out. It's called mean. Notice how it's got, means in the name, so that's why we know they go together. Mean absolute deviation. And the absolute means we're going to be taking the absolute value of something, so it's actually, useful. The measure of spread, if we're going to use the median as our center, is the IQR, or the interquartile range. Okay, and then this isn't really attached to the mode, but we do just talk about the regular old range, which is just the biggest minus the smallest. Okay, so that really tells you, how far spread out your data really is, the top and the bottom. And then the matter, the IQR, tells you how dense it is in there, in that spread. Okay, so measures of central tendency, measures of variation. So let's talk about our measures of variation. Okay, the interquartile range, or the IQR. Okay, basically the idea is you're going to find the middle of each half of data. So the first thing we're going to do, and that involves calculating the median. Okay, so we're going to, first thing, these are just your steps for calculating your IQR. First, we're going to put the numbers in order, usually from least to greatest. Okay? When you're using like a dot plot, the numbers are already in order for you, so that's super nice. Next step, find the middle, find the median, basically. So find the middle number, which is the median, which is also quartile 2 as we put these things together. Okay, now, if the median is just one of the numbers, then you're going to not count the median, and you're going to find, so if we think about it this way, we've got our whole set of data, I'm trying to decide how I want to draw this. You have your whole set of data, right? Like this. So the median is the middle number, or your quartile 2. Okay, now we're not going to include this number. And if you end up with 2 numbers, and so you have to find the middle of those 2 numbers, then, we're already not using the median. Okay, and then you want to find the middle of each half. Okay, so then you find, it's just the same exact thing. You do the front and the front and the front and the front and the front. To find the middle, the first one's quartile 1, and then the one over here is quartile 3. Okay, so let's write down the steps. Sorry, I got a little distracted. So 3, quartile 1 is find the middle from least to median. Okay, and then quartile 3 is find the middle from median to greatest. Okay, so the IQR then is quartile 3 minus quartile 1. And that tells you how spread out your data is. Okay, now if you recognize this is almost a box and whisker plot. I'll show you what those are in just a minute. Make sure you have the details on that. Okay, so that's how to find the interquartile range. The MAD, or the mean absolute deviation, here are the steps for that. First thing you have to do is find the mean. Okay, so that's the steps up here. You add all of the numbers you add all of the numbers together, and then you divide by how many numbers you added together. So you calculate the mean. Next step is you're going to subtract every data point from the mean and make it positive. In other words, we're taking the absolute value of the difference. That's where the absolute comes in the mean absolute deviation. Okay, so remember we're going to absolute value. That's like that. So, it makes -2, +2. Okay, and then, so after you get all of these differences, then we're going to find the mean of all the new numbers. Okay, so we add them all up again and divide by how many numbers that we have. Okay, I don't know that you're going to have to calculate the MAD this time around. You definitely are going to have to calculate interquartile ranges. So I'll show you some examples in a minute. Okay, if you do the assignment out of the book, one of the big questions the book wants you to answer is which measure of center and which measure of variation should you use for a set of data. Okay, so the book likes to focus on, we're going to use the mean and the MAD. Now, remember what we talked about when we were talking about misleading statistics, okay? With misleading statistics, if we have an outlier, it means the mean is not a very good measure of the middle. So the only time we can use the mean and the MAD is if we have symmetrical data. That means we can fold it in half and it matches. So if we have a dot plot, that looks like that, symmetrical data, then the best way to describe that data would be with the mean and the MAD, okay? Otherwise, and most of the time, we will use the median and the interquartile range if any data is not symmetrical. Okay, so what it means to be symmetrical, again, is you want to be able to fold it in half and it completely matches. So these two sets of data, this, we can fold it right down that 84 and it would match. Okay, this one, we can fold it right over that one and it would match. So on this one, we would use the mean and the mean absolute deviation. Okay, but looking at these box plots, and I'll talk more about the box plots in a minute, but if we fold them down this middle line, do they match? No, they don't, so we are going to use the median and interquartile range. How about those box plots? Can we fold them in half and have a match? No, again. So again, on that, we'd use the median and the interquartile range. All right, so let's talk about the next theme, which is let's give a little bit more definition to our box plots. Okay, so a box plot has several bits to it. So a box plot has a box. There's a line in the middle, and then we have lines coming off like this. Sometimes you might even have a little thing over here. Okay, that would be your outlier if you have an outlier. And you didn't want it to affect you didn't use it to calculate the rest of the stuff. Okay, and in fact, there's a really good problem on the math space set of questions that deals with how outliers affect all of this data. So that's cool. The middle line right here, this is our median. Okay, we also call that quartile 2. So that's, middle number. Okay, and then this line is quartile 3. This one is quartile 1. This is the minimum, so it's the smallest number, and this is the maximum, or the biggest number. Okay, so if we are comparing, excuse me, if we are comparing two sets of data, then we want to mention something. So to compare two sets of data, we want to say something about the center and about variation. Okay, so for example, we can look at this problem, and it says there was a survey of a different group of students in our science and math classes. The doubled blocks plot shows the results for both classes. Compare their centers and variations. Okay, so center is going to be what we have as the median in the sets of data. So the median for the math class is 10. The median for the science class is 20. Okay, because that's the middle line. Got it? 10 and 20. Now it says, so that's comparing center. Comparing variation, we're going to look at the interquartile range. Okay, so you're going to take one side of the box and subtract the other side of the box. We're going to do 20 minus 5, which is 15. And up here, we're going to do 25 minus 15, which is 10. So this is our interquartile ranges for both of these sets of data. And then it says, write an inference. You can draw about two populations. Inference just means a conclusion. What can you say about the two sets of data? Okay, now if you look at the full range of scores is actually exactly the same. It goes from 0 to 30. So interesting enough, the actual range is exactly the same. So what's different is where the center is and how spread out most of the data is. Okay, so our inferences, we could say that the science class has a higher median and the science class has more consistent scores because the spread, the IQR, is smaller. Okay, So let's see what the book says. Overall, the science student posted more than the math students. Median was twice. I mean, sure, if you want to use numbers and stuff, greater spread of data around the media for the math class than the science class. See, and I just said it's a tighter spread or more consistent data. So you can describe either one. All right, so that's kind of how that works out. Same idea here. If we compare centers, electronics is going to, in general, cost 10 more than bargain basement. But looking at the spread, the interquartile range is the same. But in general, this one has a lot, looking at the main range, that's a way bigger range. The prices are more consistent at bargain basement than they are at electronics world. Okay, this one, because the sets of data are symmetrical, we can actually use the mean and the mean absolute deviation. And so the mean is actually, I'm going to give you a little hint. When you have symmetrical data like this, the mean is the middle number. Okay, do you see that? So for Springfield, the mean is that middle number, which is 81, which is also the mode, which is also the median. So measure of center with symmetrical data is pretty easy. Now they do have you calculate the mean absolute deviation on this. So you'd have to take each one of these numbers. You don't have to worry about the ones that are on it because 84 minus 84 is going to be 0. So that's a 1, a 1, a 2, 1, 1, 2, which is 4, 4, 8. And then you'd subtract, oh, 8's the total. And then you divide that by 1, 2, 3, 4, 5, 6, 7. Actually, you'd want to do all the data points. Anyway, they've got those here. Follow my steps. My brain has decided to finish. Okay? Now on this dot plot, the numbers are not symmetrical, but you can find the interquartile range if you can, or the median in the interquartile range if you can count, but you have to make sure one hand is counting down and the other hand counts up. Okay? So I'm going to go like this. This dot, and 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 this dot. So I got in between those two dots for our median. Okay, so the median is going to be 35.5. And then to find the interquartile range, do the same thing with each half. So that's the median, that's the quartile 1. And this one, the quartile is going to be in between, quartile 3. Okay, on this set of data, okay, median is right here, in between those two. And then for the interquartile range, well, that's definitely going to be a 31. And interquartile range over here, definitely 35. Okay? And then you can compare. I think the hardest part of this is actually just writing the inferences. So if you have your book with you, it's probably a good idea to read over the different inferences that they make, because I think that's the hardest part on this assignment. Okay? So there you go. That's the that's the mathiest of the statistics we do this year. Bye.